Okay, so in this video we're going to be talking about absolute values and how to solve them with inequalities and represent them with inequalities in story problems. Okay, so just a warm up from what we did last time. So just a reminder, you work the inside first. So 9 plus negative 4 is 5, and then we take the absolute value of it. Okay, I would pause the video and I would try these and then check your answers with what I get. Okay, so negative 1 minus 5 is negative 6. Take the absolute value, we get 6. When we multiply these, we get negative 24. Take the absolute value of it, we get 24. 0 divided by negative 2 is 0, and absolute value of that is 0. Okay, so how does it relate to graphing on a number line? So it says you can solve many absolute value equations using inspection. Graph the solution set of each equation on the number line. So remember, this is the distance from 0. So if I'm doing the distance from 0, I actually have negative 5 as an answer and 5 because they are both 5 units away from 0. Okay, so my next one, to get 2 units away, we have 2 and negative 2. That is my 2 units here and my 2 units there. Can I have a negative distance? Negative distances are not positive, so this one is actually no solution. If you want to write it out, no solution, you can, because we don't have negative distances. Okay, if we're 0 distance away, we're right on that 0 dot. So it says write the absolute value equation for each solution based on the graph. So we are 1 distance away on both sides, so the absolute value is equal to 1. This one, it looks like we are 4 away, so absolute value of x is equal to 4. All right, so the official rules of baseball state that all baseballs used during professional games must be within a specified range of weights. The baseball manufacturer sets the target weight of the baseballs at 145.045 grams on its machine. So it says sketch a graph that models the relationship between the manufactured baseball's weight, x, and its distance from the target weight, y. Explain how you constructed your sketch, then write an absolute value equation to represent the situation and the graph. Okay, so this is my weight in grams. That's my x, and then my y is the weight difference. So my first weight in grams is 145, so if I follow my weight in grams, my first dot would be like right in here. Okay, so that point is kind of like 145.045, comma 0. Okay, so if we threw him in the absolute value, we have y equals, we went right that amount. So remember, left and right, it goes on the inside. So saying right, I had to do a minus 145.045. Okay, so then it says the specified weight allows for a difference of 3.295 grams in the actual weight of a ball and the target weight. So I can go either way, 3.295. I can go down or I can go up. So since the weight must be within a distance of 3.295 from the target weight, y equals 3.295. So it says graph the equation y equals 3.295 on the coordinate plane in question 1. So I actually need to graph this V shape. So what I would do is I would type this in my graphing calculator and look at the points that are closer to your x value being around 145. So you're going to have to scroll a decent amount. And to do this a little bit easier, what you can do is press second table set, and then it says table start. I started my table at 145, and then I went back to it. So it started me at 145, and I can see now my left and right. So I can look at 142 is at 3, so 142 is pretty close to 3. Okay, if I did, let's say 140, so I'm going to scroll up, it's close to 5. If I do 138, it's close to 7. Now I have to do my other side, so I probably want 146 is pretty close to that. So let's do 148, which is close to 3. Otherwise, you're just going to have to scroll a lot. Okay, 150 is close to 5. So here, now I can actually do my next question, which says to graph y equals 3.295. So it's a little bit above. There we go. It says graph the equation, okay, in question 1, boom. What 2 equations can you write without absolute values to show the least acceptable weight and the greatest acceptable weight of a baseball? Okay, well, if I take my original equation, x minus 145.05 Okay, I could do the positive side of 3.295, and I could also do the negative side, where if I added that 3.295 and subtracted that 3.295, because I have the leniency of going both ways. So it says use the graph to write the solutions to the equations in part B. I think it's a little bit easier to just solve. So this, just add over, and get your two answers. Okay, so my two answers that are going to work is 148.34 and 141.75. So I can kind of work both those directions. All right, 2.2. The two equations you wrote can be represented by the linear absolute value equation, okay, which we've kind of talked about. And remember, absolute values we flip, so we did the positive and negative side to it to solve any absolute value equation. Recall the definition of absolute value. So if I have this, we had the positive and negative sides to it. So when we rewrite it to get rid of the absolute value bars, we're going to do the positive side and the negative side to include the distance from 0 on the negative side and the positive side of it. Okay, so in this example here, when we go to write it, you have to do the positive and negative side of it. Okay, so in this they applied the negative side and the positive side. So it says, how do you know the expressions positive A and negative A represent opposite distances? So for example, if I took 6 and negative 6, they represent opposite distances because if I added them, 6 plus negative 6, it would get me 0. Okay, Martina and Bob continued to solve the linear absolute value equation, absolute value of x minus 1 equals 6 in different ways. Compare their strategies and then determine the solutions to the equations. Okay, so Martina looks like it made 6 and negative 6, and Bob tried to only flip this left side. Okay, so if we solve them, we're going to check to see who has the correct answer. All right, so if I take x minus 1 is equal to 6, I would add 1, get x equals 7. This one I would add 1 and get x is equal to negative 5. Okay, my next one I would add 1 and get 7. This one I would subtract 1, get 5, divide by negative 1, get negative 5. Okay, so if I checked my answer and plopped it back in, they should work, right? So it looks like we got the same answer for both. So if I test 7, if I throw in 7 minus 1, which is 6, take the absolute value at 6. If I throw negative 5 in, which is both of them, negative 5 minus 1 is negative 6. Absolute value of that is 6. Okay, so they both kind of work. One just, Martina divided both sides of the second equation by negative 1, and then Bob distributed the negative 1, getting the same answer. Okay, so solve each linear absolute value equation and show your work. Okay, so to get rid of those bars, we have to include the positive side and the negative side. So both of them I'd end up subtracting 7, so I get negative 4 and negative 10. Okay, this one here, I do x minus 9 equals 12, x minus 9 equals negative 12, add 9 for both of them. So I would get x is equal to 21 and x is equal to negative 3. Okay, can't have a negative distance that we're equal to. No solution. Okay, my next one, 2x plus 3. I can't have a negative or positive 0, so I only have to solve one equation in this one. So then I have 2x is equal to negative 3, divide by 2, negative 3 over 2. Okay, so this one it says Artie, Donald, Cho, and Steve each solved the equation absolute value of x minus 4 equals 5. So it looks like what Artie did was he just threw a negative on his x. Donald, he added the 4 first to get my 9s, and then he flipped them, making the x negative. Okay, Cho, it looks like he applied the negative to the whole thing before he did anything, and then kept the other side normal. And then Steve only applied the negative to the x and the 5. Okay, so in this one, Cho incorrectly applied the negative symbol to the -4 in the second equation. Steve incorrectly applied a second negative symbol to the -5. Okay, so already applied the positive and negative signs to the expression inside the linear absolute value symbols and then solved each equation. Donald isolated the linear absolute value expression before applying the positive and negative symbols to the isolated expression. So that was kind of the similarities and differences between those two guys. Okay, so I would pause the video and then I'm going to go ahead and quickly do this and then you can kind of check your answers for it. But what I like to do first is always get the absolute value bars by themselves. So like I'm going to subtract 16 before I do anything. And then I'm going to go into my split. So positive 16, negative 16. So this one, to get my bars by themselves, you subtract 6. So 17 equals absolute value. Okay, now to get rid of the bars, we go into our split with our positive and our negative. So I'm going to end up adding 8 for both of them. So -9 and 25. Okay, there's a multiplication sign that sits here, so to get rid of it, I need to divide by it. Never, ever distribute into those bars. They're like walls that you cannot enter. Okay, and then to get rid of my walls, we go into our split, where I add 2 to both and get 6 and -2. Okay, so get rid of things not attached, then get rid of the things attached. So I've got 45 equals 5 times x plus 6. Divide by 5. So 9 equals x plus 6. And then go into my split with positive 9 and -9. Okay, so you determined the linear absolute value equation from before to identify the most and least a baseball could weigh and still be within the specifications. The manufacturer wants to determine all of the acceptable weights that the baseball could be and still fit within the specifications. You can write a linear absolute value inequality to represent this problem situation. Okay, so it says, write a linear absolute value inequality to represent all baseball weights that are within the specification. So I know it has to be less than or equal to that 3.295. So when I do it, I want it less than or equal to that 3.295. Okay, because I can't be bigger than that. So it says use the graph to determine whether the weight of each given baseball is acceptable. Substitute each value into the inequality to verify your answer. Okay, so if you look, you're substituting it in for the W and seeing if it works. So in this one you would be doing 147 minus 145.05 and seeing if it's less than or equal to 3.295. This one you'd be plugging the 140.8 in if you're doing it mathematically. Okay, otherwise you're going to see if it is within that parameter of your line. So what you're trying to see in the graph is when you do the number, so like let's say I pick 148.34. 148.34 is going to be somewhere in here. It's got to be within like this section. Okay, it's kind of hard to tell on this one and this one to see if they're within. Okay, and this one even. But 147, you can see if I follow 147 up, there's a possibility of it being in that range. So when it says look in the graph, you're kind of seeing, is it going to be in that little area where they would share? Okay, so mathematically, if you type them all in, you should get yes, no, yes, and yes for it working. Because these three are kind of hard to tell based on the graph if it's going to be within that parameter. Okay, so it says use the graph on the coordinate plane to graph the inequalities in the number line showing all the acceptable weights. Okay, so we already on the original, we said it would go from 140 to 1.75 to 148.34, or you're just going to add the 3.295 to this and then subtract it to get your parameters again. Okay, and then we're just going to graph them on here. So 141.75 and then 148.34. Okay, and then if you want to rewrite it, because this is kind of confusing, if I do the split right here, 141.75 less than or equal to W. If you want to do the shortcut of the arrow cheating, you have to make sure that W is facing the opposite way. It has to come first. So right now it's being eaten, so I'm going to make sure I eat it again. So that means my arrow is pointing to the right, so it's going to shade right for that one. This one, my W is on the left-hand side, so my arrow is pointing left, so it shade left. So those are all my possibilities that should work. Okay, so if we completed that 145.75, 148.34, which is kind of what we wrote up there. Says Raymond has the job of disposing of all baseballs that are not within the acceptable weight limits. Write an absolute value inequality to represent the weights of the baseballs that Raymond can dispose of. Okay, so it has to be less than 145.75 because we can be that, we just can't, oops, other way. We just can't be, we can't be less than that, okay? And then we can't be more than the 148.34. We can be it, which would be that equal to, okay, but we can't be more than that. So graphing this inequality, this one will be the easier one to do. So open dot, we can't be more than it. And then if I flip him to make it easier to look at, so 145. Oop, he was supposed to be 141. There we go. Okay, 141. Can't be anything less than that. All right, in Little League Baseball, the diameter of the ball is slightly smaller than that of a professional baseball. So for a Little League Baseball, the manufacturer sets the target diameter to be 7.47 centimeters. The specified diameter allows for a difference of 1.27. So it says, sketch the graph of the linear absolute value function f of d on the coordinate. Use the graph to estimate the diameters of all the Little League baseballs that fit within the specifications, and algebraically determine the diameters of the baseballs that fit within the specification. Write your answer in the inequality. All right, so it looks like here, diameter league of the baseball. So to make it, we got y equals diameter league. We have to go right, which is why it's a minus here. So if I graphed him, 7.47 is going to be kind of like this. Okay, go ahead and type it in your calculator. So math, absolute value, x minus 7.47, graph. Okay, let's see. I want to start at kind of the 7 area. Got a lot of decimals. Okay, it looks like 9 is 1.53, so 9, 1.5 is kind of here. 8 is 0.53, so kind of here. Okay, 6 is 1.47. 5 is 2.47, which is going to be way up there. Let's see if we can get 7 is 0.47. Okay, and then that 1.27 is going to be like my y equals. So if I go to 1.27, it's going to be right there. 7. Okay, so if we were trying to figure out the biggest and smallest, I could add that 1.27 or subtract that 1.27, or I could see where those 2 points hit. So if I take 7.47 and I add 1.27, the most we can go is 8.74. And then if I subtract it, the least we can go is 6.2. So the manufacturer knows that the closer the diameter of the baseball is to the target, the more likely it is to be sold. The manufacturer decides to keep only the baseballs that are less than 0.75 centimeters from the larger diameter. So algebraically determine which baseballs will not fall within the new specified limits and will not be kept. Write your answer as an inequality. Okay, so now we're trying to do 0.75 away. So I want, if I subtract, okay, it's going to be 6.72 and 8.22. Okay, why did I do this? Less than this and greater than this when last time they were flipped. I don't normally want greater than that number or less than this number, except for this time it says will not fall. Okay, so we actually want ones that don't work in this situation. All right, absolute value inequalities can take 4 different forms as shown in the table. To solve a linear absolute value inequality, you can first write it as an equivalent compound inequality. Okay, so we have some different equivalent compound inequalities, so that means multiple things happening at once. It says solve the linear absolute value inequality by rewriting it as an equivalent compound inequality, then graph your solution on the number line. Okay, so if we follow it like this up here, it says we do -4 x plus 3 and 4. Okay, I always rewrite it here. So I do like a splitsy here, and I do -4 x plus 3, and then I do x plus 3 is less than 4. Okay, subtract 3, we get, let's see, we get -7 is less than or equal to 7, less than 7, -3. Okay, but this is facing the wrong way, so I have to go in and I flip it. X is being eaten, so I eat x again. So now I'm at -7. So I put an open dot at -7, and I shade everything to the right. I put it open dot at 1, and it looks like I shade everything to the left because that's the way my arrow points. That's the way my arrow points. Okay, so my next one here, if I'm following, it looks like I am eating the absolute value, so you would follow this route if you want to be able to do it. Otherwise, what I say is just do the double flip. So I keep one normal. Let's keep it written the same way to make it easier. So here's my normal one, and then I flip for my next one. Okay, so I have -6, I flip my inequality, and that's my next one to solve. So I'm going to add 4, divide by 2. Oops, that's a 5, not a 10. And then flip my inequality to make it easier to graph. This one I add 4. Divide by 2. Flip my inequality to make it easier to look at. So it's going to be at -1, close dot, shaded to the left, and at 5, close dot, shaded to the right. Okay, so this one, remember, always get absolute value bars by themselves first before you do anything else. Okay, and then your next step is keep the one normal, double flip the next one. So -5x plus 8, flip. So I'm going to subtract 8. Divide by -5. When I divide by a negative, it flips my inequality. Okay, so subtract 8. Divide by -5. I just divided by a negative. It flips my inequality. And I'm going to turn this to a decimal because it's going to be a little bit easier for me to put on my number line. Okay, so it looks like they're both open dots. So open dot at -3, shaded to the right. open dot at 6.2, shaded to the left. Okay. This one's a little weird. Normally we had no solution for this one. Okay, actually for this one, we're going to have all real numbers be the answer because there are multiple answers that are going to be greater than -1. So like if I test this out, let's say I pick 3. 3 plus 5 is 8, absolute value of that, -1. Let's say I pick -10. -10 plus 5 is -5, absolute value of that is 5. Still works. Let's say I picked 0. 0 plus 5 is 5, absolute value of that is still bigger than -1. So your answer for this is actually all real numbers because there are no numbers that are going to get me to be less than -1. Okay, this one, I have to think of values that will get me less than -1, not greater than -1. There are no numbers that if I plug it in here will get me less than -1. So if I tested all those ones up there again, so 3 plus 5 gives me 8. If I do -20, -20 plus 5 is -15, absolute value of that still gets me something bigger. If I did 0, 0 plus 5 is 5, still doesn't work. So this one actually is no solution.